Hello students, good morning, good evening and good night, depending on which time we are going to observe this lecture. Welcome to the third lecture on alcohol, phenol and ether chapter. In this lecture, we are going to discuss the preparation of alcohols. So, today's heading of this lecture is today's lecture, the topic we are going to discuss. So today we are going to discuss the preparation of alcohols. Alcohols can be prepared in different ways and from different reagents also. That it can be prepared from alkenes, it can be prepared from alkyl halides, it can be prepared from Grignard reagents. That we will discuss in detail in this lecture. This is K.K. Mukherjee in the Science with Mukherjee Sir YouTube channel. So first we are going to discuss the first thing, that is the hydrolysis of alkyl halide. In presence of KOH, aqueous solution of KOH, when we react with alkyl halide with aqueous solution of KOH, it will going to produce the alcohol. Suppose this is we are taking X. X can be chlorine, bromine or iodine. So KOH plus as per this KX. This is the first way, that hydrolysis of alkyl halide. Second way that we can prepare, that is on the reduction of second process of preparation is reduction of aldehyde ketones or carboxylic acid, then esters. By reducing all these carbonyl compounds, that we can able to prepare the alcohol. First reaction that we are taking, suppose this is aldehyde. When aldehyde when reduced in presence of hydrogen and finely divided platinum, nickel or palladium, we can find that it has been reduced into the primary alcohol, 1 degree alcohol. And this reduction process is called the catalytic hydrogenation. Second, from the ketone. When ketone is reduced, suppose the reducing agent is lithium aluminum hydride, at that time it will going to prepare the alcohol, which is 2 degree alcohol. Carboxylic acid when reduced, this is carboxylic acid, and when it is reduced with the same reducing agent lithium aluminum hydride, and it will going to produce the primary alcohol. Fourth one, that is ester. Ester, COOR. This is ester. Ester is being prepared with the help of alcohol and the carboxylic acid, and when it is being reduced, reducing agent is copper chromate. Copper chromate you are using as a reducing agent, so at that time it will produce this alcohol. Two alcohol it will produce. One alcohol will have the alkyl group which is present in the carboxylic acid, and another alkyl group which is present in the alcohol. So two alcohol has been prepared from this. So we can understand that is by reduction of the carbonyl compound we can able to produce the alcohol in these four different ways. Now it is the another way that is going to be very, very helpful, that is from the Grignard reagent. We are going to discuss from the Grignard reagent. Grignard reagent. Grignard reagent, we know that is a very special type of organic compound. We can say it is organometallic compound, where you can find the presence of the metal as well as the organic alkyl groups. So at that time, from the Grignard reagent, we form the aldehyde, and from the ketone we can able to produce the alcohol. The general reaction is like this. General reaction is this. This is the aldehyde or ketone, where this is H and R. Then it will be aldehyde. When both is R, that is alkyl group, then we will say it is a ketone. And Grignard reagent is RMgX. X is the halogen, Mg is metal, and R is the alkyl group. So what will happen? Slight positive charge will be created in the magnesium atom, and slight negative charge will be created at this alkyl group. And here, due to the higher electronegativity of this oxygen atom, this electron will be shifted here, and it will have the negative charge, and this central carbon atom will be positive charge. So what is going to happen? This alkyl group will be attached to this, and this remaining part of this Grignard reagent will be attached to this oxygen. So it will create a adduct. This is called a addition compound. This is a, here you can observe R, and here OMgX. This is a addition group, addition compound, which is a adduct, you can say. And this adduct, when being hydrolyzed by H plus or H, it will hydrolyze, it will be going to produce the alcohol. So this will be the alcohol, and according this also product is also there. So from the Grignard reagent, when we react with this aldehyde or ketone, it will going to first we will going to produce this intermediate product, and it will then will hydrolyze, and it will going to give you the alcohol. From formaldehyde. From formaldehyde, when beginner reagent is used, what is going to happen? It will produce this R will be attached to this, and this mgx, suppose X is we are taking Br, mgx will be added to this oxygen atom. So this product will be this. So mgBr, and it will be here R, and this product will be R CH2OH and MgOH Br will be hydrolyzed in presence of acid. So from formaldehyde we can have the alcohol which is primary alcohol. But if it is the acetaldehyde, suppose, or acetaldehyde, or we can say it is aldehyde, any other aldehyde, acetaldehyde, when this R will be CH3. So this will be, the product will be, that we can easily understand, that here R will be attached here and H will be attached here after the compound. So this will have the RCH R and OH. So this alcohol from this aldehyde will prepare, and that will be the 2 degree, means secondary aldehyde. If it is a ketone at that time, you will have the alcohol, that will be, you will have alcohol that will be the 3rd degree, means tertiary alcohol. So only from the formaldehyde we can able to produce the 1 degree alcohol, and with other aldehyde or ketone we will observe that we will going to produce the secondary or tertiary alcohol. Okay, so from the beginner reagents, when we are going to react with the aldehyde or ketone, it will go into different types of alcohols. Okay. 4th number, that is from alkene. From alkene, there are 2 ways by which we can able to produce this alcohol. A, by acid hydration, by acid catalysis, acid catalyst hydration of alkenes. In this way we can able to prepare the alkene. The reaction is this. This is the alkene. When it will going to react with H2O in presence of H plus, it will be basically a addition reaction, and we will observe that hydrogen H plus ion and OH minus ion is added to this alkene, where there is a double bond, carbon-carbon double bond is present. This is very simple, but when there is the unsymmetric alkene, suppose unsymmetric alkene means this alkene is unsymmetric. At that time, the addition of this H plus and OH minus ion will be in which place? That will be governed by the Markovnikov rules. Markovnikov rule. What it says that we already learned in class 11, that in that case the addition of the OH minus ion, that is a negative ion, will be at that carbon atom which is under double bond, where there is a less number of hydrogen atom. Means here the OH minus ion will be joined here and H plus will be joined here. So in this case the alcohol produced, alcohol in OH will be attached there and hydrogen will be attached here. So at that time the alcohol prepared, we will say this is propane 2 all, right? And the mechanism of this acid catalyst, which is hydration of the alkene, is basically 3 steps. There are basically 3 steps you can observe. Number 1 steps, you can write the mechanism is 3 steps. The first step that we can see, that is the carbocation. The alkene has been production, or we can say that transformation of alkene into the carbocation. Transformation, we can write transformation of alkene into carbocation, and this reaction will be like this. First H2O will be converted into the hydronium ion, H3O plus ion. This is basically now as a electrophile and it will attack the alkene. It will attack the alkene. So we can write this hydronium ion in this way. Hydrogen, hydrogen and this hydrogen. Here, as because of this fact, oxygen, in the oxygen there is a development of the positive charge. It will take off this bond pair electron of the hydrogen between hydrogen and oxygen to itself, and the transferment of the movement of the electron is like this, and this free electron in the alkane will be taken up by this H plus ion, so it will become a carbocation in this way. Here you can see hydrogen and here you can see the carbocation, and there is the H2O produced. So this is the first step where the alkene has been transformed into this carbocation. Now the second step, nucleophilic attack. Nucleophilic attack of the H2O to this carbocation. So in this case you can see hydrogen, this is now carbocation, and this carbocation has been that there will be attack of this nucleophile, that is H2. H2 is a nucleophile, so this will be bonded, this oxygen will be bonded with this places of the carbon where there is a positive charge is been occurred, and that is, you can see carbon, hydrogen, and this carbon and O, this is H, and this is this. So this is a place. So here you can see there is a positive charge in this oxygen atom because the electron has been taken up by this positive charge of this carbon. So now this is the second step, and third step you can see that is the deprotonation. Deprotonation. Deprotonation means there will be the removal of this H ion, H plus ion. So from this you can write this reaction will be like this. And this is a positive charge. So here what is happened, here oxygen will take up this electron pair to itself, and now this hydrogen is free as a H plus ion, and this will be taken up this by this electron. So ultimately the alcohol is being formed. You can see the alcohol is formed. Alcohol is formed now, and there is, you can see, the hydronium ion has been returned back. So alcohol is being formed here with this third step. So you can understand there is basically three steps: transformation of alkene into carbocation, then nucleophilic attack of H2O, and third is deprotonation of this product has been created after the nucleophilic attack. So there is a three steps. We can see the acid hydration of the alkene. Way that we can able to use, we can able to have, that is the hydroboration. Hydroboration and oxidation. This is also a step by which we can able to convert alkene into the alcohol by the reaction of the diborane. Suppose we have taken this alkene, unsymmetric alkene, and this has been reacted with B2A6, and this will first create the trialkyl borane. This will first create trialkyl borane, CH3, CH2, CH2, and this. This is the trialkyl borane, and this trialkyl borane is oxidized in presence of H2O2 and aqueous solution of NOH, and it will going to produce the three molecules of this propane 1 or alcohol. This is propane 1 or alcohol, and this product will going to produce. So this is the way by hydroboration, also oxidation, we can able to produce this alkene. But what is the difference between the acid hydration and hydroboration, that you can able to understand? In this case we have been able to prepare the propane 1 all, where we to work. So it can be perceived as the addition of the OH, the H2O, and in anti-Markovnikov way. In the first time that acid hydration, you can see the addition of the H2 is the as per the Markovnikov way. Here it is A as per your anti-Markov way. And process first, the fifth process, that is, we can see The alkane can be prepared by the action of the nitrous acid. Nitrous acid with aliphatic amine. With the aliphatic amine and nitrous acid, you can able to also produce this alcohol. And the reaction is this. This is the aliphatic amine and this is nitrous acid. Nitrous acid can be prepared by NaNO2 with HCl. So this is going to produce this alcohol. But in this process, this is not a desirable process, because from this process there will be the alkene has been produced. There is a different type of organic compounds is found to be produced. So that is all for the preparation of the alcohol. We have understand there is the 5 ways by which you can able to prepare the alcohol. First, from the hydrolysis of the alkyl halide. Second, from the reduction of the carbonyl compounds, that is your ketone, aldehyde, carboxylic acid and esters. Third, from the Grignard reagents. Fourth, from the different type of from the alkenes by acid hydration and by hydroboration and oxidation process. And fifth, that is the action with the aliphatic amine with the nitrous acid. That is all for today's lecture. Next lecture we are going to discuss the another thing that is in this chapter, it is the preparation of the phenols. Hope all the points have been clear to you, and that will be very helpful to you in your studies to understand this concept of the preparation of the alcohol. Thank you very much for watching. If you like this video, you can share to your friends. Thank you.